Alright guys, I think I got cut out at the very end of that last video. The point I was making is that if we wanted the probability that a person will be between 68 inches and 73.6 inches, then we would just shade that area under this curve. Now, there's certain parts of the area under this curve that are not shaded. Alright, right here, this is not shaded. And this part on the right side is also not shaded. So we have this whole area under the curve, but only this middle part is shaded. And we want to know what percent of this whole area under the curve is shaded. And so it's hard for, it's going to be hard to know with the curve like this. I'm just telling you that the percentage of this area under the curve, it's not half of it is shaded. It's going to be 68% of it is shaded. Now, if 68% of it is shaded, then that means that if I were to pick a random person off the street, there's a 68% chance that that person's height is between 68 inches and 73.6 inches. Alright, that was the same thing that we were saying here. Alright, it says Jaden takes the same bus to work every morning. The amount of time y in minutes that he has to wait for the bus to arrive on a randomly selected workday morning is described by the density curve that follows. And it's this weird one. It's not a bell curve like we have over here. It's just a rectangle, meaning that the relative frequency of any given time period between 0 minutes and a 10-minute wait is equally frequent, equally likely. Alright, so he's just as likely to have to wait around 10 minutes as he is to have to wait around 5 minutes as he is to have to wait around 0 minutes, because the height is the same throughout. Now, the area under this curve, alright, it's going to add up to 1, and what percent of that area is accounted for in this little green box where he's waiting between 0 and 2 minutes? Well, we said that that's 20% of this total area. This total area we'll say is 1. All right, and what percent of that is shaded? 20%. So there's a 20% chance, therefore, that he has to wait between 0 and 2 minutes. By contrast, this shaded area, all right, takes up 25% of this entire area under the curve. And so there's a 25% chance that he has to wait between 3.5 minutes and 6 minutes. Now I want to just do a few more varying examples. Alright, so here the length is 3. So when we're trying to do our probability calculations for this, let's say I want to know the probability that our variable, whatever it is, all right, that it's going to be, so we'll say probability that our variable x is going to be greater than or equal to 2. All right, so we're going to have 1 right here and 2 right here. All right, the probability that it's going to be greater than or equal to 2, it's going to be that shaded area. All right, now what's our length here? What's the length between 2 and 3? That's going to be 1. But what do we multiply that by? Well, if this whole area of this rectangle must be 1, all right, must multiply, that if this whole area must be 1, and the length of the whole thing is 3, then the height has to then be 1/3, because 1/3 times 3 is equal to 1. All right, and so that we have a total length of 3, a total height of 1/3. You multiply the two together and you get a total area of 1. So what about this shaded region, the probability of x being greater than or equal to 2? Well, we know that its length is 1, but its height is going to be 1/3. So the probability of that x is going to be greater than or equal to 2 is just going to be 1/3. All right, now what's the height of this one going to be? Here, x can be anywhere between 8 and 15, whatever this variable is. We can make it time to finish some task, and it takes anywhere from 8 to 15 minutes. Each of these possible time values is equally likely because our height is constant throughout. All right, well, what's the length here? What's the difference between, what's the distance from 8 to 15? Well, that distance is 7, right? That distance is going to be 7. So that means that our height has to be 1 over 7. So then when we multiply this distance, or this length of 7, times our height of 1 over 7, it'll give us 1. So what's the probability that x, all right, takes anywhere from, we'll say, 11 to 14, all right? Or what's the probability that x is somewhere between 11 and 14? So in other words, what proportion of this entire thing am I shading? Well, what's the difference, the distance from 11 to 14? All right, that distance is going to be 12, 13, 14. So that distance is going to be 3. All right, again, 12, 13, 14. So I went over 3 units, so that's its length, times the height, which is 1 over 7. So the probability that this variable, whatever it is, I'm being very vague, just so that I can make a general point, the probability that this variable will take on a value between 11 and 14 has a 3 out of 7 chance, or a little bit less than a 50% chance. All right, now, bonus opportunity. Here we have a slightly odd probability curve density right here. All right, it's not these rectangles that we've been dealing with, and it's also not this bell curve that you've seen with heights and grades and so on. All right, it starts off high at 2, and then it goes down, declines till it gets to 1, and then it stays consistent throughout. Here's the different possible x values. Here's the bonus. Email me with your answer before our live meeting for bonus points. Here's the bonus. It'll be bonus points on one of your your next quiz. All right, 5 extra points on your next quiz. What is the probability that our variable x, all right, here's our variable x, which can take on the value of 0.1, 0.2, 0.3, 0.33, 0.37, 0.4, and so on. What's the probability that x is going to be, all right, greater than or equal to 0? X is, all right, x is going to be greater than or equal to 0, but less than or equal to 0.2. All right, if you can email that to me before our live meeting, then you will get 5 bonus points on your quiz. Good luck.